For our model, the magnet was modeled as a magnetic dipole while falling through aluminum foil, and our assumptions were that air resistance is negligible and the gravity and magnetic force from the aluminum tube are the only forces on the magnet. So for our initial conditions, the magnet acted as a dipole, the aluminum foil could conduct electricity, and the force of gravity equals mg. For our system, it was the magnet and the aluminum foil, and our surroundings was everything else. Our procedure was that the magnetometer on the phone marks the north pole of the magnet, and the camera was used to record the magnet being dropped through the aluminum foil tube 5 times. The video was used to calculate the time taken to fall and the average of these times. The length of the tube was 0.32 meters, width of aluminum foil was 0.006 meters, inner radius was 0.02 meters, mass of magnet was 0.024 kilograms, magnetic dipole moment was 3.206, and the average time taken to fall through the tube was 1.26, and the time taken was 1.32 seconds. Why was it not a ferrous tube like a steel pipe? Ferrous tube contains irons, and this could act as an induced magnet, which would affect the falling magnet. What happens to the magnet? How does this compare to a magnet falling in a free space without a tube? So the magnet falls significantly through the tube than if it were dropped through free space. In our computation model, you can see here's the start of our code, and we had to initialize the important constants as well as creating the graph that we would plot what we needed to plot on. Here we added more numerical constants. We created our aluminum tube model, and we created our bar magnet model. And we defined the functions for the magnetic field from the dipole, and we created the function for magnetic flux from the bar magnet. The red ring represented the north pole of the magnet, and the blue represented the south pole. And for our computational model, our predicted time was 1.3 seconds, while our actual time was 1.26 seconds. The intensity of the coloring on the tube indicated the magnitude of current flowing through each ring. Red and blue indicate current flowing in opposite directions. Which color corresponds to the clockwise current as viewed from above, and which corresponds to the counterclockwise? How can you know? From above, the red current is counterclockwise and the blue is clockwise, found by Lenz's law. What happens to the dynamics of the system when you flip the magnet around? If the magnet was flipped, not much would change. The magnet would fall still, and the direction of the current would flip. How does the total in-tube time of your real-world system compare to that of your computational system? How might the computational system be made more accurate? Both values were close, but could be more accurate by splitting the tube into more rings. What does the shape of the velocity versus time plot tell you about the forces acting on the bar magnet? The shape shows that the gravitational force and magnetic force are unequal and become equal as velocity is constant, and they become unequal as gravitational force becomes greater. For our model discrepancies, there were none, and the magnet is accurately considered as a dipole for our model. And for our sources of error, there could have been human error with timing from the video. We also assumed that air resistance was negligible, which may or may not have been true, and there could have been other magnetic forces affecting the magnet in the surrounding area. What if the resistivity of the conductor was reduced as close as possible to zero? How would the dynamics of the falling magnet change? The braking forces would increase enough to balance the gravitational force, and this would prevent the magnet from falling through the tube. What if holes or slots were cut into the tube? How would this affect the ring currents in your model? Holes would disrupt the normal flow of current through the rings of current in the tube, and the braking force would not be as strong as the current would decrease.